This is page 8 of our notes. My colors today are purple and black. This is a continuation of NS.4. There's a lot of pieces to standard NS.4 that will help you understand what all we're going to do there. Today we're going to talk about prime factoring. And this is going to help us with greatest common factor, least common multiple. It'll even help us with distributive property. These are all things we learn with NS.4. So prime factoring, if you remember, we're going to talk about the term prime factor today. And we actually talked about both of these separate in our notes back on page 6 and page 7. So if you need to look back, that's fine. But factors, if you remember, were numbers we multiplied to get an answer. So I might have said, what are the factors of 8? Those were numbers you could multiply to get 8, like 1 and 8 and 2 and 4. Prime numbers were numbers that had to have exactly 2 factors. Prime numbers have exactly 2 factors. So those are numbers like 2. And its factors to make it prime would be 1 and 2. That gives you 2. Another prime number was 3 because it has exactly 2 factors, 1 and 3. Another prime number was 5. Its factors were 1 and 5. So what do you think a prime factor is? Well, it's basically a prime number that's also a factor of whatever number you're trying to find. So it is a factor of a number and is also a prime number. So it has to be a factor, which means you could multiply it to equal a number, and it also has to be a prime number. So in today's prime factoring notes, put a star here, the directions say, write 18 as a product, so product means we're multiplying, of its prime factors. Give you a chance to write the directions. Those are kind of confusing, so we're going to talk about that. If you're writing 18 as a product of its prime factors, we're going to do something that I call the ladder method. So 18 is our number, so I'm skipping a line. And then we're going to make a rung on this ladder, like this, a rung. You put a line down and then you put it underneath of there. It kind of looks like a ladder. What you do is out here on this side of 18, we are going to be putting prime numbers outside. So I'm going to write that over here, maybe put a little star next to that. You have to look for prime numbers on the outside. Prime would be like numbers like 2, 3, and 5, 7, because they are numbers that have exactly 2 factors. Now you also need to put a number out here that goes into 18. So if I put a number like 2 out here, it's prime, it has exactly 2 factors, and it goes into 18. What happens when I take 18 and divide by 2? I get 9. Now, am I going to make another rung on this ladder? Is there another prime factor that I could put out here that's a prime number that also goes into 9? Sure, 3. 9 divided by 3 gives me 3. And 3, I would not make another rung here because you can't divide this down. It's a prime number, so you can stop. So circle all your prime numbers, which are 2, 3, and 3. You're going to notice that it's the ones on the outside and on the bottom. And if you're going to write 18 as a product of its prime factors, you could say that 2 times 3 times the other 3 equals 18. And that's what they're wanting you to write it like this, as like a multiplication statement. Notice I did not say 2 times 9 equals 18 because 9 is not a prime factor. 9 can be broken down into 3 and 3, so it was not prime. It's actually a composite number. So what should you have learned with this method? We call it the ladder method. And I remember it because it looks like rungs on the ladder, like you have a little rung on the ladder going across. So this is the method I would like you to use when you're solving prime factoring. You may draw a line here in your notes or do another example. What if I ask you to write, instead of 18 as a product of its prime factors, what if I ask you to do 60? So 60 is our number. We need to put a rung on the ladder because I know there's some numbers that you can put here. You could put a 2 on the outside because that's prime. And you could divide by 2. You could put a 5 on the outside. It's prime. Doesn't matter what order you divide by, you still get all the prime factors. So if we choose 5, 60 divided by 5 is 12. So I'm going to write the 12 right under the 60. Do I need to make another rung on the ladder? Is there another prime factor that goes into 12? Yes. Let's make another rung. You could do 2 or you could do 3. So let's go 3 this time. 12 divided by 3 is 4. Do I make another rung here? Is there something we could divide by 4? Yep, 4 could be broken down into 2 and 2. This number 2 is prime, so I can stop. Circle all your numbers on the outside and on the bottom. Those are all of your prime factors. So if you take 5 times 3 times 2 times the other 2, that all equals 60. And this entire thing is your answer. You box in the entire thing for your answer. So why didn't I just start with 12 out here and divide and get 5? Well, you don't want to put numbers like 12 on the outside. Remember, the outside have to be prime numbers, which means they have exactly 2 factors, 1 and themselves here. So those are all prime on the outside. Let's try another example. Draw a line. Okay, the next example, I'm going to move this up, is 36. So if we're going to express 36 as a product of its prime factors, you would have 36. Can you make a rung on the ladder? Yep. You can divide it by 2. You could divide it by 3. So let's say you do 3. Then you'd be left with 12. And we actually did 12 up here. So what could you divide 12 by? It has to be a prime number on the outside. So don't put 4 over here. You could put a 3. And that gives you 4 down here. 12 divided by 3 is 4. You can make another rung because you can divide 4 by 2 and you're left with 2. These are prime numbers. Can't get any smaller than that. So how do I write it? 3 times 3 times 2 times 2, and that all equals 36. Now, could I have said 2 times 2 times 3 times 3? Sure, they're the same thing. It doesn't really matter what order you write them in. Let's do another example. So the next example is 78. Well, I know it's an even number, so I know I can at least make a rung on the ladder and divide it by 2. Maybe I don't know how many times 2 goes into 78, so I have to show out here on the side and actually divide by 2 and actually try. 2 goes into 7 3 times. I get 6. I'm ready to subtract. I get a 1, bring down the 8. 2 goes into 18 9 times. 18, subtract, and it was zeros. So 39, so I'm ready to put 39 here. Now I'm looking to see, is this prime? Does anything go into this? Well, I know I could put 3 goes into 3 or 1 time, and 3 would go into 9 3 times. So I can make another rung on the ladder, and I can put a 3 out here. 3 is a prime factor that goes into 39. 3 times 1 would give me the 3, and 3 times 3 would give me the 9. 13 is prime. You can circle that, circle these. So how would I write 78? You could write it as 2 times 3 times 13 equals 78. And you're going to box all of that in for its products of its prime factors. So the homework that you're going to do to practice this standard, your homework is a worksheet. It's like 1.2. You are going to do numbers 3 through 13 odds. I'm skipping number 1 because number 1 is the same table, the same chart of prime numbers that we already have. So I'm not making you do it again. So 3 through 13 odds. And I would like you to try number 18. So that's your homework to practice this assignment.